Application of RULA and NIOSH Ergonomic Risk Assessment Methods, a case study in construction industry in Turkey. Abstract. According to Occupational Health and Safety Risk Assessment Regulation in Turkey, the identification of hazards in all workplaces are necessary. A risk assessment should be performed to eliminate the hazards and monitoring control activities in all workplaces. The aim of this study is to analyze the working postures of construction workers and to make ergonomic risk assessments using RULA and NIOSH methods. Furthermore, it is aimed to reveal ergonomic hazards and risks during construction works and to suggest possible prevention ways. Workers in a construction company, which is operating in district Kartal of Istanbul in Turkey and located on the Asian side of the city, is examined and 9 different kinds of construction-related activities are evaluated. RULA method is applied for preparation of plaster mortar, metal cutting, die cutting, roofing, welding, concrete crushing, drilling and plumbing processes. In addition, NIOSH method is used for brick stacking process. The risk scores are evaluated, and prevention measures are recommended to prevent possible injuries. Keywords: ergonomics, occupational health and safety, RULA application, NIOSH application, construction sector. Introduction. The responsibility of the employer, as indicated in the Risk Assessment Regulation of the Occupational Health and Safety Act No. 6331 Turkey, is to ensure the health and safety of workers, to manage risk in terms of occupational health and safety and to maintaining and improving evaluate. According to Turkish Statistical Institute 1 Statistics Annual, 7% of the working population in Turkey is employed in construction sector. Thus, the number of people exposed to ergonomic risks is not small to be underestimated in this sector. According to the Social Security Institution 2, occupational diseases of the musculoskeletal system have a ratio of 7.5% among the total occupational diseases. Lower back disorders are the most common problem among musculoskeletal diseases. 3. Awkward back postures, use of vibrating tools or equipment, and carrying heavy loads are effective in the occurrence of low back pain. 4. It was reported that there is a high prevalence of back pain of the workers who have awkward back posture and undertake heavy physical work. 5. Occupational low back pain occurs due to awkward postures during lifting, pushing, pulling, or carrying objects. Eventually, frequent low back pain becomes a common cause of disability. 6. Low back pain is the second most common cause of labor loss after influenza infections in developed countries and is considered the most important factor affecting the decrease in production. 7. The estimated prevalence of low back pain is 5 to 20% in the USA and 25 to 45% in Europe. 7. It was reported that the rate of low back pain is higher in blue-collar workers than in white-collar workers. 8. Schneider & Co-workers 9 showed that there are many ergonomic risk factors such as bending, creeping, squatting, kneeling, climbing, standing and balance in construction works. Lowry et al. 10 mentioned that, in their study on 32,081 workers in the construction of Denver International Airport, it was observed that lift assembly operations take the first place among the other operations in terms of lost work time, and they reported that the employees cannot come to work for an average of 46 days as a result of accidents. Parada and Ray 11 stated that construction workers have a high risk for musculoskeletal disorders, especially with the effect of lifting and carrying heavy loads. Damland et al. 12, in a survey of semi-experienced construction workers, stated that 65% of workers suffer back pain. Lee and Lee 13 determined that the main sources of physical workload among construction workers are poor posture, repetitive using of various parts of the body, vibration, and static standing. Sporrong and co-workers 14 showed that an important part of the works in construction sector is carried out at raised shoulder positions with muscle activity. Various studies have shown a strong relationship between exposure to physical loads such as heavy load lifting, static muscle loading and bad working postures, and increase in musculoskeletal disorders. 15, 16. In 2003, Merlino et al. 17 conducted a study among young construction workers. About half of the workers described the static standing at work as a major problem contributing to musculoskeletal problems. They found that working in the same position for long periods and extreme bending and twisting are among the first 3 factors leading to musculoskeletal symptoms. Arndt et al. 18 emphasized that common practices such as heavy lifting, repetitive motions increase the risk of injury. Lee and Han 19 evaluated 8 different works that were performed during construction and found that the most common bad postures occur while working by 2 hands with the arms above shoulder height and also while standing long term by bending the body, arms, and feet. Kulkarni and Evalker 20 found that among construction workers, awkward lower body postures, repetitive work and bending of wrists forward and back are the most important factors that increase the risk of cumulative trauma disorders on shoulders, knees, feet, wrists, and back. Haydarnzad et al. 21 found that the prevalence of work-related musculoskeletal disorders in the knee, wrist, shoulder, waist, and feet are high due to joint contact stress, lifting, or carrying heavy items, working with heavy equipment, long working hours and necessity to work fast. In Turkey, the number of accidents in construction sector too and the consequences of these accidents are significant for workers, organizations, society, and countries. Thus, occupational safety and health has become a very important issue. Ergonomic factors play a substantial role in body posture and movement like sitting, standing, lifting, pulling and pushing. 6. The goal of this study is to examine the working postures of the workers in the construction works by RULA and NIOSH risk assessment methods, and the risk levels were determined accordingly. 2 materials and methods. The study focused on 9 different kinds of construction-related activities. RULA method 22 is used for plaster mortar preparation, metal cutting, die cutting, roofing, welding, concrete crushing, drilling and plumbing processes. Furthermore, NIOSH methods 23 is applied for brick stacking process. According to the data of the Kartal Municipality Directorate of Construction License and Inspection Affairs 24, There are 524 active construction work in Kartal district. The selected company is one of the construction firms. Afterwards, legal permissions are obtained and the postures of the employees are photographed in this construction company, which is operating in district Kartal of Istanbul, Turkey. Photographs are taken only at one construction site. The ergonomic risk analysis methods are carried out by giving numerical values to the body postures of the employee and risk level values are determined. 3 results. Brick stacking process. Within the scope of the construction project, unloading and stacking of bricks process is seen in Fig 1a. A floor crane is used to carry bricks from the ground level to higher level. The bricks are carried by a crane with basket and unloaded from the basket to the floor and the bricks are stacked on top of each other at horizontal and vertical distances as shown in Fig 1b.